then multiply by height. So multiply by height. Okay, so we can name this height. Maybe we can say if this was maybe f, we could say multiply by af, depending, or if we just say the height is just h, then we can say multiply by h, like half times bc, then times height, which is h. Okay, so now we're going to go to examples and then we're going to round it up. Okay, so here are the examples that we have. So I'd like to start over here and then we're going to move to this part, then the last part. Okay, so here is just a right angle triangle. So if you want to find the area, remember for a right angle triangle, it's half then times the base and multiply by a height. So we have half then multiplied by the base is BC, and then this is the height, which is AC. Okay, so to get this BC, you can see, since it's a right angle triangle, you can use what? The Pythagorean theorem, the Pythagoras theorem. So what you know is x squared and plus y squared is equal to r squared. So x, which is bc squared, plus y, which is 5 squared, is equal to 9 squared. Therefore bc will be equal to 9 squared minus 25. So it's going to be 81 minus 25, which is 56. So bc squared is equal to 56, then bc is equal to root 56, and root 56 is 2 root 14. And then you come back, since half times the base, which is bc, and then the height, which is ac, then it is half then times the bc, which is 2 root 14, and then times what? Times AC, which is 5. Then these two cancels that 2, so you have root 14 times 5, which is 5 root 14. So square units. So that is how you would approach this problem. So I have these as more like as first orders. So these are the easy type, and then it's a little bit challenging, not much though, at the bottom. So now that we are done with this one, now we are moving to more like number 2. So I could say this one is number 3, 1, 2, and 3. And then here, you remember this was more of the third case. So we were having more of part of a triangle. Say we have a triangle, slant triangle, and now it's ABC. And then if you want to find the area, so it's more like the area of triangle ABC, you use half base times height, half base times height. This you use using the base, which is BC, and then the height, which is 4. So it's going to be half then multiplied by the base for this triangle ABC, which is 2.5, and then multiplied by a height, which is 4. So multiply by 4. So what do we have? So half times 4 times 2.5. Then what you get is 5. So you have 5. So it's 5 square units. So I'm going to write it as 5 square units. Alright, now we're going to move to the last one and then continue. So for the last one, of which I'm going to do it just over here. Okay, for the last one, we also have to find what the area of triangle ABC, and what we said is we want the angle to be included. So to have something like that, if we want to use angle A, if we were to use angle B, we will be using this and something here, of course, of which we don't have. So to use angle B and to use angle C, you recall that we're using this side and then this side, so that the angle is included. So it's more like between the angles. So what we're going to have is half and then multiplied by the included sides is okay, the sides, so it's what is 3,2 and then multiplied by what, 3,5 as sine theta, sine the angle in between, so it's angle what is 20 degrees, sine 20 degrees, and then you just find your area. So it's half then multiplied by 3,2 times 3,5 times sine 20, and then this is equal to more like 5,11. It's more like, it's approximately 5,11, so square units. Okay, now we're going to get to the second ones. Then the last one is I want to us to find what the areas of what of triangles. Okay, I want us to find areas of triangles between within what parallel lines. Okay, so we're going to start with this one, and then this one will be 2, and this one will be 3, just like we did with the top. So what we have here, we have 45 degrees and 45 degrees, so this is 90 degrees. So first that we will be saying is that this angle and the angle, and then it's more like here we have 90 degrees. Okay, and then what else can you say is that if we have a side, this side is 6, so this side will be 6 because the sides are equal. So that is what we are having, and if we have 3 and 6, we can use the Pythagoras to find this side, because remember, this is the question. You have to find the area for what, for the blue triangle. So we're trying to find the area for the blue triangle. Now we have this side and then this side, so what you are left with is finding this side through a Pythagoras, and then you are done. So this is a triangle that we have, and we have a 90 degrees over here, and then we have 45 degrees and 45 degrees there. So what we have is 3, and then we have 6, and then this is unknown. So this is unknown. So this is okay, it's not me. So we have A, and then we have C there. So what we're going to have is the area. You can call this one F. So the area of triangle ABC AFC will be equal to your half, then multiplied by your base. Okay, this is 6. Okay, this is 6. So it's is half, then multiplied by the base. The base is what is FC, and then the height is what is AF. So we can try and find FC first using Pythagoras. So remember that x squared plus y squared is equal to r squared when you're using Pythagoras. Then your x squared is FC squared, then plus your y squared, which is your 3 squared, is equal to your 6 squared. So this is 36 minus 9. So 36 minus 9 is 27, and then we just have to root 27. So FC is the square root of 27, which is 3 root 3. So we have half, then multiplied by FC, which is 3 root 3, and then multiplied by AF, and AF is 3. So this becomes a 9, then 9 over 2 square root of 3. So it's 9 square root of 3 over 2 square units. So for number 2, we have A, and then we have B, and then we have C, and then we have a D. So here is a B, which is perpendicular, and then we have a C. So what we have is also a 3 and then N5. Okay, and if we want to find the area of what of ADC, so this is what we are looking for, the area of this triangle. So what we know is this is 5, so, and then this one is 3. So it's more like we can find this length of what of BC if we have this one is 5, and that is, oh god, oh dear. Now on number 2, we have A, B, C, and D, whereby we have this perpendicular height for B. Then we're going to suppose that as BD, we're going to suppose that BD is equal to maybe 6 unit. So we can say it is 6 or 7 units. Let's say 7 units. Then you have to find the area of triangle ADC using the information given. Okay, remember that the area is what is half base times height. So the area of triangle ADC is equal to your half, then multiplied by your base, and your base is what is DC, and then times your height, and then your height times your height, which is AB. This is what is going on. This is the triangle that we are looking for, and then we know that this is our base, and then this is the height. Okay, and I just have to remind you again that the height cannot be AC. AC is length, and then we are not looking for its length height. When we're doing like triangles, we are looking forward for a perpendicular height. So like we are looking for a perpendicular height. So we just want to know that from the base of the triangle, how high the triangle have risen up. So that is why we are looking for a perpendicular height. We are interested in how high the triangle has risen up rather than looking at it like that. It wouldn't make much sense. So now that we have to continue, we're going to find DC. So we're going to find DC, and to do that, since we know that this side is 5 and then this one is 3, so we can find BC, and then we could subtract BC from what, from BD, which is given. So we can say that x squared then plus y squared is equal to r squared, using Pythagoras theorem. So we can see that x is what is BC squared then plus a y squared, which is 3 squared equals to 9, and then your AC squared, which is your r squared, which is 25. Then 25 minus 9 is 16, and then BC will be equal to 4. Will be equal to 4 units. So we can say that this is half, then multiplied by your DC is now what? Is now 7 minus 4, which is equal to 3. So it's 3, then multiplied by your AB, which is 3. Then this is 9 over 2 square units. So for number 3, we have 30 degrees, and then we have 40 degrees, and then so this one should be 20. Okay. And this one should be 30 plus 40, which is 70, and then it's 180 minus 70, which is 110 degrees. Okay, so we have angle. This is angle A, this is angle B, and then this is angle C. And further we are given that this is 5, and then this one is 7. Remember that if we have to find, we find the area of triangle ABC, we take the angle that is included between the two sides. So you can see that if we have 5 and 7, so we're going to use B. So it's going to be half, then multiplied by the first side 5, and then the second one 7, doesn't matter the order. So times what? Times sine that angle 110 degrees. Okay, so let me remove this. So it's angle 110 degrees, and then I just have to punch it my calculator. So the area is 0.774 square units. So square units. Now we're going to go to the last one, and then I want to explain the areas between parallel lines. So in this example, I want to show you that the areas between parallel lines. So we have parallel lines BC, which is parallel to DE. So we have BC being parallel to DE, and then what I want to show you is that the area between the parallel lines are going to be equal. So these areas that I'm talking about, so for this triangle looking like that, and then the triangle looking like this. Okay, so the areas for a triangle, so we have a triangle looking like this, and then we have another triangle. So we have another triangle, a white triangle looking like that. So to start with the first triangle, I'm going to remove this portion, and then this is the triangle B, C, okay, D. So it's more like DBC. So the area for of triangle DBC, this is the triangle that I'm talking about. So we can just draw what a perpendicular. So we can draw just a perpendicular height along the base, which is BC. So it is half, then times the base, which is BC, then times what the height. So we can say that this is just the height h. Okay, but if we are using the base BE, you're going to see that these areas are going to be equal to the one for the white triangle. So this is what a plumb triangle. So let's look at the area for a white triangle. So here we go. That's a white triangle, and then it also have a base which is BC. Remember, for the first one we used a height, so there was our height, a height h. So that was what height h. And then even for this one, if we're using the base which is BC, and then we can see that we can draw at a perpendicular height, and then this height is actually equal to this height. The reason is that we are more like forming what a rectangle. So when we form a rectangle, so the opposite sides are going to be what? Are going to be equal. So this is also height h. So we can say that the area of triangle, so since this is E from here, so we have area of triangle, what? ECB or BCE, so it's BCE. We can say that it's equal to half, then multiplied by your base, which is BC, and then your height here is your height h, so times your height h. But then what you notice is that this area is actually equal to this area. So if the areas are equal for triangles under what? And or between parallel lines which share what? The same base. So we can say that if triangles are between parallel lines, parallel lines, so between parallel lines and share a same base, they will share a same height and be perpendicular. So they will share the same height and have equal areas.